Is there like a sound in this?
Yes, there will be.
Little class, Pauling math here. A little number not a great mathematician, Mr. Whitman. When I find myself in times of trouble, the wise teacher comes to me, speaking words of wisdom, letter E. In my hour of darkness, he was standing right in front of me, speaking words of wisdom, letter E. Letter E, letter E, letter E, letter E.
Just enjoy it for what it's worth. It's tacky is bad.
Everyone would agree there will be an answer.
Oh my God.
When the situation it is natural for all to see. There will be an answer. Letter E. 2.7, 1.2, 8.8, 2.84. 5904, 93, 36, 28, 74, 71, 35, 266, 249.
It's just so bad. Do I need an excuse to show you something ridiculous every once in a while? This is what it talks about.
That's all you know.
God, there's still another 50 seconds to go of Chad. Alright, I've got enough of this. Yeah, because it's over. I get it. All right. Anyway, letter E. Letter E. The letter E is what they call natural base. What happens here in this simple scenario, 1 plus 1 over n to the nth power. As n approaches infinity, as n gets larger and larger and larger and larger, that value is approaching 2.7182, 818, 284, 593, 674, 454, 668. I'm making up numbers. You don't care. Anyway, so yeah, I'm a moron. So what happens here is you have. Oh, sorry. Oh, I'm sorry. Now, what happens here is that when you're dealing with the value of e, just like we did with variables, when you have e squared times e squared, it becomes e to the fifth, or e to the fourth, excuse me. Your power rules and your exponent rules still work the same when you're dealing with values of e. You're not going to be calculating values of e. You're not going to be pressing buttons on your calculator. Just like we did with pi, you would leave pi in your answer. You'll leave e in your answer. It's more useful as we get into some of the compounding interest style problems, word problems. We will do some graphing with this, but once again, your graphing, you're just going to be able to show the parent function and a shift. And a lot of times, you're only going to be able to show like 2 points with an E graph. They're very, very, very simple. So let's look at a couple of quick examples. We good? Yeah. All right. Let's look at a couple examples of how you would simplify expressions in terms of E. Like I said in part A, if you have E cubed times e to the fourth, it's e to the what? E to the seventh. Very good. Your exponent rules still hold true. 10e to the third divided by 5e squared. Ladies, remember, deal with your numbers first, and then go to your variables with exponents. 10 divided by 5 is 2. E cubed over e squared, so it's 2. All right. And then lastly, you have 3e to the negative 4x all squared. So once again, worry about distributing in your power first. So you have 3 squared e to the negative 4x squared. So when you have power to power, what do? Ooh, multiply. So you wind up with 9e to the negative 8x. Is that e happy? No, it's a sad e. Not happy, it's sad e. So that's 9 over e to the 8x. Okay. Those exponent rules still hold true. You will see them from time to time. You're not going to be solving a lot of equations or anything like that. One of the things you will do, though, with these is we will graph. And like I said, the graphing with e is the easiest graphing there is. I didn't even mean to make that fun. That's funny. With a PH, get it? Funny, fun. Sure. Anyway, do we all know where the E button is on our calculator? Let's find the E button. Here's the calculator. The E button is second divide. Letter E. Letter E. Letter E. Letter E. E squared equals what? 7.38905. So you can sing Let It Be to anything. So I just wanted to show you guys where it is on the calculator because you will use it when you're going to graph. So speaking of graphs, you can graph these as well. They will look just like exponential growth and or decay problems. But once again, I don't want us to get involved with knowing exactly what all these little decimal values are going to wind up being. I want us to be able to get the general idea of what it looks like as a parent function and then what your shifts are. So let's just jump right into how we graph these. So what I'd like you to do is keep the calculator out, and I want to graph y equals 2e to the 0.75x. I want to graph that. Yeah, let me move the source so I can get this. It'll be 2e. Now, here's what you got to be careful with. When you raise the exponent to the e value, I know that you guys have the different operating systems. I want to see if it works okay in yours. Because mine, I got to put a bunch of parentheses around it. All right, yours, you'll be okay. Yes, you will have it in your head for about 1.5 years now. So e to the in my calculator, I have to put parentheses around it. You guys won't have to. Yeah, I forgot. You really don't really super need it, but yeah, that's not a bad idea. These we can probably get away with some rough sketches.
We do rough sketches.
What's that?
We just rough sketches.
Well, I still want you to be able to show the shifts and everything, but you still got to be able to do the shifts. You know, if that makes sense. So even though you're doing rough sketches, you still have to be able to shift.
But I can't.
So when I go to this, when you go to your table on that, you're going to see that you really have no easy numbers at all to plot, except for one of them. Why is that an easy one to plot? It's y-intercept. Okay. So since that's going to be your y-intercept there, what happens here is you just plot your y-intercept. Do you guys see any h or k tacked onto this one? No. So this would wind up being at 0, 2. So all you have to be able to do here is figure out exactly, rough idea. At 1, it's at 4 point something. At -1, it's at a little less than 1. And then it's tailing off. So it's doing this. Okay? Where is the asymptote here?
0.
0, very good. So what is your domain? All reals. Your range. Is there such thing as -0? Right, there's no -0. Does this thing have a bottom to it? So it's everything greater than 0. Like all reals greater than 0. Okay? So everything's got to be greater than 0. Now, if the graph was below something, it would just be all less than. So all you got to do is really just kind of look at the way the graph is to know where you're at. Remember, your asymptote, since there is no k value, is there. And that's really all you're going to be able to graph. All right? You will always be able to graph your y-intercept. Give some points on either side. It is going to be a little bit difficult to plot 0.44626 on a graph paper, but it's about halfway. Yeah, it is kind of difficult to go through that. All right. So now, what do you think is going to change when you have shift then? Nothing. Nothing's going to change. You're still going to graph that parent function and then shift it. So in this case here, actually, let's see here. If the book tells you to do that way or not. I've done it a couple different ways. So in this case, oh yeah, okay. What do you think your parent function is going to be?
E to the -0.
Perfect. So your parent function, well, first of all, your h is going to be 2, and your k is 1. You guys agree on that? Your asymptote then will be at 1. Your parent function is going to be y equals e to the -0.5x. Plot that first, which means just put in your calculator. So according to my table, the parent function, at 0 and 1, and then I'm just tailing down. At -1, I'm a little bit more. -2, I'm up here, and so on. So here is your generic first. From that, where do you move it? Yeah, to the right 2, up 1. Right 2, up 1. Right 2, up 1. Right 2, up 1. And we're tailing down. And your new asymptote is at okay? Once again, in this case here, what is going to be your domain? Domain's all real. And then your range is going to be everything what? Good. Range is going to be all real greater than 1. Okay? Like I said, graphing these are going to be very simple. You're really only going to get one point that actually looks like at a real spot. And then it's just a matter of shifting your ranges in your case. Okay? Your range is going to be all reals greater than 1. Y values. Think of it this way. Some of these graphs are going to be tailing down like that. Some graphs should be going the other direction. So if it's coming from the top down, you've got a floor. And if it's coming from the bottom up, you've got a ceiling. So if it's a ceiling, it's going to be less than. If it's a floor, it's going to be greater. Does that make sense?
Yeah.
Okay. So now, the whole idea of using the letter E, except for singing great snappy tunes, is for using word problems. And if you are in econ, you probably have seen this before. The PERT formula, you know, for when you have dandruff. You okay there? Anyway. When you have the initial amount formulas, the principal to the rate over the number of times something's compounding to the number of times compounded per years, when you have what's called a continuously compounding interest style problem, you use the basic formula. The amount is going to equal the principal. That's what P stands for. I'll just do this. Is that okay? Bless you. So when it says the principal, that's kind of like the exact same thing as the initial amount. Okay? So if you go to start a savings account, your principal might be $500 if you start a savings account, or $20, whatever you've got. The R is still your rate. So it is a as a decimal again. Okay. That is still that value. So then the last part of there is T for the number of years. Okay, T is your number of years. That E here is the E button on your calculator. All right, the E is going to be the E button on your calculator. What happens is that this formula is a little bit easier to use than that one. That's all. It's a little bit easier to remember. Okay. So this is very simple to see when it says it's continuously compounded. Those are the catchphrases that you're going to see. So for this example here, you're depositing $1,000. You're going to deposit, and the next problem was you're going to deposit $1,000 into an account that compounds continuously at 8%. All right, good. So you have an account that pays 8% annual interest compounded. What's the balance after a year? So that means your principal is how much? 1,000. What's your rate? 0.08, good. And in this case here, what's your T? 1. So in your calculator, you're just going to type in 1,000 e to the 0.08 times 1. Should be 1,080, I believe. So you get $1,083.28. Huh? Always round you money. Yeah. I said that right. Oh, I meant to say 20 minutes. Now, what will it be after 6 years? Yeah. So what do you do then when you change, if I want to find out how much it's going to be in there after 6 years, what do you change t to? 6. So here, if you have a problem like that, which you will see from time to time in the calculator, you can go back and re-edit your formula or just retype it. 1,000 e to the, well, my calculator had to the parentheses, 0.08 times 6. And your calculators, you can actually just leave that 0.08 times 6 in the calculator because your exponent stays above, and it knows to keep that multiplication there. And you should still get the same answer, 1660 and 7 cents. Not too scary? Remember the other day when we had formulas like these, and then I would ask you how long would it take to be at a certain value? Remember how you put those in the table function to figure out the amount of years? You're going to do the same thing with this as well. Right? You'll do the same stuff with this. For example, in this case here. Since 1972, the U.S. Fish and Wildlife Service has kept a list of endangered species in the United States, like the warthog. For the years 72 to 98, the number of S species on the list can be modeled by 119.6 e to the 0.0917 t, where t is the number of years since 1972. Okay. What was the number of endangered species in 1972? How many years have elapsed from 1972 to 1972? Give me one. All right. So you, in your calculator, I do not know. What is it? You know, the woolly mammoth is very endangered because it's dead. Speaking of endangered species, I don't know what the most endangered species is. I thought it was a panda or the white leopard, maybe. Is it deaf leopard? What's that? Hold on, I can't hear what endangered species are. I thought those were already extinct. 5?
Can you look it up?
Later. So, what was the number of endangered species in 72? Can you have 0.1 endangered species? So what'd you get for this? About 131 of them. Now, when it says graph the model, are you going to graph that? No. When it says use the graph to estimate when the number of endangered species reaches 1,000, how do you do that in your calculator? Go to your table. Very good. So in my calculator, I type that formula. Obviously, your calculator does not have a button that says t for the variable, so you just use x. So in the calculator, we have y equals, what was it, 119.6 e to the 0.0917x. Oh, I didn't get parentheses in there. One thing that's... all right. Did you guys get an answer about how many years it's going to take? How many? 23, 24 years. Okay. So see how this is about the same thing that we did last time when you had to scroll through your table function to find the stuff? I know, I hit the button too many times. But you get the idea? Like I said, this TERT formula, P-E to the RT, is very easy to use. There's not a lot of craziness involved to it. Okay?
At least I have a book. Really, I don't. I give you enough time. I know. I got a $40 check last night. Huh? Shot glass night. How'd you get shot glass? Check glass.
Oh, wait, hold on. That's... Does that make sense? That should be good. Yeah, it's pretty simple stuff. All right?